Hello everyone and welcome to our YouTube channel. We are working on a series of videos on MPI and this is our third video on that topic. If you haven't watched the previous ones, do check them out to get a better idea of MPI. So let's get started. So today we are talking about MPI collective communication. So it's just as the name applies. Collective communication are the functions that we use when we want to transmit data from one point to multiple points. So in point to point, what I was doing is I was transmitting data from one point to another. But in collective, I am basically spreading the information to all the available points. And what are the functions that are included in it? So there's one of the most important ones, MPI broadcast. Will basically broadcast. So I'm spreading the information exactly as I defined before. So what happens is generally rank 0 is considered the master thread, master process, and we use that to transmit data to all the other sub processes. That's what we term in MPI. That's what the terms are used. So broadcasting means sending from one to all the other. And then for synchronization, and if you have been studying parallel programming, you must know that synchronization is a very crucial part of parallel programming. We need to synchronize all of the processes within our program. Why do we need to synchronize? Well, let's say I want to gather output from it, the program that was running. Since it's a parallel program, so the initial input was split into multiple processes. But when I want to take the final output, I want it to be a combined single answer. And and you must know that some processes can be faster than the other. In that case, the order can get disturbed. So I can overcome this problem by synchronizing the processes to, let's say, get the outputs in a particular order, so that the final output is not some jargled mess. And for that, I can use the MPI barrier command, which is let's say, which basically means I am setting up a barrier here and you all have to wait until everybody is finished. Next is MPI reduction, and that is basically combining all the processes, combining the output from all the processes into a final output that will be displayed to the user. Okay, let's get to it. This is the demo program for that. And in this program, it's pretty similar to the other two. We have MPI init, so I'm initializing MPI, POM rank, so saving the values of all ranks of all the processes to this address. So and rank means I am referencing to this variable, and that's the address of this variable. Similarly, I am saving the size, that means the total number of processes in this community, to this variable. And now I'm running an if statement. If rank is equal to 0, number is equal to 50. So I initially defined a variable number int, and then I gave a statement number is equal to 50, and I did that in this if statement, that if rank is equal to 0. So only the process 0 can access this if thread, if loop, and number is defined inside of this block. So what will happen is only rank 0 will be able to access this. You will see in the live program that this statement is actually written here to show that only rank 0 is able to access this block. And then I'm broadcasting number and number, that means that's a reference to this variable, to the world. I am broadcasting this number, the value of number, to the entire world. So that means all the processes. And then I'm printing that this number has received, this rank has received that, this rank process has received that. Okay. So let's get to a live demo of this. So currently I'm logged into a HPC node and I am inside the RPCN. So RPCN is basically a CPU node, and I'm inside that node of the HPC. The HPC I'm working on is HPC param rudra. So let's load up a few modules. I need open MPI 4.1.6 to use MPI. Okay, I forgot to use the load. Now it's fine. Let's clear this. Let's check the program. So it's the same program as in the PPT. We'll compile it and we will run it. So let's do MPI C++ because the program is a C++ program, capital C. Do MPI collective. Oh, we're in the wrong directory. I need to go to the MPI programs directory first. And then I'll do MPI C++. So MPI collective.c. Can say it takes some time to compile. Yeah, it's done, finished. It's finished compiling. Yeah, I reopened this program. That wasn't my intent. Okay, I want the mobile TE for this. Yeah, this is just for some help to me. Quite a long statement, quite a complicated statement to remember. So MPI run, that's a standard for MPI. And why do I need this? I need this part to remove the warnings. I'll show you what I mean. But first, let me just run it once. Let's run the program with 4 processes and see the output. Okay, so process 0 broadcasting number 100. Okay, so in the program, I have if rank 0, rank is equal to 0. I have printf this. Okay, only process 0 printed that. So that means it is verified this loop is only accessible by rank 0. But number was defined inside of this block, right? Inside of this block, which is only accessible by rank 0. And as you know, MPI processes are completely independent of each other. That means they do not share any variables unless and until specified by the code. So the only way the other processes could have known that number is equal to 100 was that when I broadcasted it to the entire world, they found out. They received that information and they printed it. And yeah, as for the why do I need this part, I will show you. That's better than explaining. Yeah, because I'm getting this error. So why do I get this error, you ask? Because I am working in a HPC, and as some of you may know, HPC is basically multiple computers connected to each other via either Ethernet or a InfiniBand in this case. So what happens is the MPI has an instinct. It tries to access the InfiniBand. But since I have not implemented any programming for that, it fails. It simply fails to access that. Neither have I implemented any programming, nor am I connected to multiple nodes, so it won't be able to access it. And all of this warnings and all are kind of obstructing the output. So just to make it look a bit cleaner, I have to implement this. It suppresses the warnings. Okay, let's try one more time, and let's change. 45 is a little too much. Let's try it with 5. And I have received the same output. Let's try changing the number for once. Maybe okay, now we'll have to compile again. Let's run the program. Yeah, so I have received the same output again. No difference. That means our program is working fine. So where do we need to use these kind of collective communication processes, functions? Wherever we need to control multiple processes at once, whether it can be data or the actual processes themselves, then we use collective communication functions, as it helps us to avoid writing a lot of code, first things first, and it also helps us moderate the data. How? The reduction function that I mentioned in my explanation. It helps us to collect the data from all the processes and combines it into one single output. So that is it for this video. Thank you for watching.